Alrighty, so I'm going to go ahead and I'm going to share the screen. I'm going to bring up the assignment itself, and we can just quickly go over it. And if we have any real problems, we'll, I guess we can discuss it there. Hold on.
Okay.
All right, you see this?
Yeah.
All right. So, okay, what is the sampling distribution?
I put it was the distribution of all possible means for a particular sample size.
That is about what I concluded myself. It's just basically taking it from the actual population, like you said. So,
yeah.
So, okay, what is the shape of a sampling distribution of the sample mean when the data are normally distributed? Normal, from what from what the reading and what the in the actual reading and what the videos discussed.
I think they make it confusing because at first I thought they wanted like the actual shape of it, but they're talking about what the shape could be, I guess, or what the shape means.
Well, I think you can't. I think it did say. I read in one of the questions. If you answer, if you did say bell shape, it will also be correct.
Okay. And I don't feel so bad because that is what I did.
Okay. What is the shape of the distribution of a sample means when the data are normally distributed, but the sample size is large? For what I read,
approximately normal.
Yes, and I don't understand exactly why it's called approximate normal. Is it because it's not a normal, but through the size is being so large, it becomes approximate? Is that what?
Yes.
Okay. All right. All right.
That's exactly it.
All right. 4. How does the shape of the distribution of sample means change when the sample size is increased? From what I understand, it actually I'm not quite sure. How does the shape of the distribution of sample means change when the sample size is increased?
Well, the answer key says the sampling distribution more closely approaches a normal distribution and the standard deviation decreases. And the mean is unchanged.
Okay, that makes sense.
I don't know how they came to that conclusion because I couldn't figure that one out.
Okay, so yeah, okay, now my memory is coming back. So with the larger we have a larger size, and it goes right back to the sample size will help bring it to normal, the approximate normalcy, right? And then so that helps to create the shape. Now the standard deviation, just by the formula itself, you take the mean. If the mean doesn't change, the sample means change when. How does the shape of the sample means change when the sample size is increased? According to this, it says no change is increased, but because the sample size and the sample size and the population are the same, and so what happens is as you do your math, the standard deviation will get smaller based on. So if it's one,
well, the deviation will get smaller, but the mean won't change.
That's correct. That is correct. So that's just because as the larger it gets, the formula will automatically put it to a smaller decimal or a smaller size. So does that make sense? Because it talks about it. So
I mean.
Oh, go ahead.
I guess it does, but like none of this really makes sense to me until I apply it. And if we're just talking about it, I'm never going to figure it out. I mean, if there's a formula that I need to figure it out, then I could probably do it.
I'll type it out for you. Okay. So let's just say the mean is 10, and the formula for standard deviation on this is this. I don't have a square root key.
I don't either.
Just say, I'm going to say square root. Of 100. So that's 1 divided by the square root of 100 is 10. So it becomes 1, right?
Mm-hmm.
So now sorry. Now as you have a larger population, which would be, say, in this 1,000, right? Okay, maybe I got the, hold on, let me just get the formula right.
Yeah, the interesting thing is I watched all the videos, I watched the tutorial, I did all of that. But
yeah,
I mean, it just doesn't register until I actually have to use it, you know? So which number needs to increase? The 10 or the 100?
Well, so for the formula itself, it talks about doing, so on standard, on number 8, it talks about what is the standard deviation, the distribution of the sample means for the score. So the formula is 113 divided by 10, where 10 is the square. So so right here is your sample size. This is the standard deviation.
Okay.
So
yes. Okay.
So if I'm correct, so let's do 1,000. Let's do so 10 over becomes 1. But now let's talk about. But I don't understand this. It doesn't make sense now, because if I increase the sample size, let's move it to 1,000. Let's just make it 144. So 10 divided by the square root.
Okay, so if you have 10 divided by the square root of 100, it's 100.
Right.
So then if you do that by 120.
So 100, oh, I'm sorry, not 120, 144. That makes 12.
Okay.
So 10 over 12 is 1.2. So, but that doesn't make sense then, because now it becomes larger.
No, it doesn't. Because if you do the first one, the 10 divided by the square root of 100 or whatever, you have 100. But if you have 10 divided by the square root of 144, 0.8333, whatever.
Yeah. So that's right. So I was thinking the opposite. I'm sorry. For whatever reason. Okay. So does that make sense now? Why the standard deviation decreases as
yes.
Okay.
Because I do. I'm not going to try to explain it to you though.
But I'm saying, if you could, all I care about in math is if I can apply the formula, the numbers to the formula, and it gets the right answer. I don't have to always explain it, because I'm not a mathematician.
Yes.
Okay. All right. When is X normally distributed? When it's, if I'm correct.
The X bar is normally distributed if the data were drawn from a normal population, or if the sample size is sufficiently large.
So talking about from the theorem and from the central limit. Okay, sorry, we skipped over 5.
Number 5.
Central limit theorem and law of large numbers. Central limit theorem talks about the actual
it says that
the sample size
go ahead.
is large, and when a large number stays as the sample size increase. So the central limit theorem is saying is large, then therefore it will become an approximate normal distribution. The law of large numbers states that the sample size increases as it increases, the standard deviation and sample mean will get smaller. So it talks about, whereas this large number talks about the standard deviation of the sample mean will get smaller. So
it's basically what we just did in number 4.
Basically, in a sense, yep. And X bar is normally distributed if the data were drawn from a normal population, or if the sample size is sufficiently large. Again, talks about the central limit theorem, and also, okay. All right. So in part 2 talks about random. So if you wanted to play the game, I actually did this. I actually opened it up. I opened this random.org, and these were my, hold on. This is, where is that? These were my numbers that were given. So, and then you look on the key. So what's 28 and then I take the numbers. I didn't do all this, so and then basically whatever the number that the means comes out, these come out on the chart. So if it's 42,000, you just put it into a Excel and then do an
Find
average.
the mean, right?
Yep.
Yeah.
And then do an average on it all, and then talks about what does the sample mean? Well, that's depending upon what you did. This graph. There are 142,506 possible combinations of 30 salaries drawn, 5 at a time. This graph represents a distribution of all sorts. Mark on the horizontal axis to indicate the value of your sample mean from part A. So that again depends on where you drew. So if I put that all into a calculation in Excel and then do the formula. Average.
Well, the answer I got when I did mine was 44,880.
So
I put that on there, and I thought it was not unusual because it was within the inside of the bell shape. Maybe I'm wrong, but that's what I concluded.
Okay.
Am I wrong?
No. I mean, if you're within the bell shape. And also, how far are you away from, so where's my question is, where's the standard deviation on this?
I don't know.
I mean, what you can do is just take that random sampling. You can take all these numbers that are in here and then randomly do a standard deviation. And that will give us the right answer. But, and if you're off by, 1 or 2 standard deviations away from it, then yeah.
Well, so mine was 44,800.
Mm-hmm.
And I figured the mean was probably like 46.5, about the middle.
Yeah.
So I didn't think I was too far from it. I mean,
no.
Maybe I'm wrong. I don't know, but I just thought it wasn't unusual because it was still inside that.
Yeah. I mean,
now if it was like 34,000 or 60,000, I would have thought that it was unusual.
Mm-hmm.
Right?
Right. So I don't have any dispute on that. Unfortunately I didn't do that sampling myself. I got to the random.org and was able to come up with my numbers, and if I wanted to, I can apply those right away. So, okay.
Well, letter E is out.
Yeah. So going to 8A. So let's go 8A. Okay. What is the shape of the distribution of the sample of such a means? Well, from what I understand of such a sample, it says normally distribution, which I don't understand why it would be.
I don't either. I feel like there's not enough information to show me how they come upon that answer. This is very vague.
Mm-hmm.
And so it's hard for me to draw conclusions when I don't understand it in the first place, so I don't know how they came upon that.
Yeah, see, what I don't understand is when it comes to a normal distribution is when there's a large number to conclude from that.
Well, it says, what is the shape of the distribution of the sample means for all such samples?
How do you know?
Graduate management admission test is used in admission criterion. Are normally distributed with a mean of 529 and a standard deviation of 113. So we're considering a simple random sample.
Mm-hmm.
For 10 students taking it.
Mm-hmm.
So is there somewhere that we should plug in these numbers?
Well, that's what I'm saying is that when I understood when you have a sample size large enough that therefore will classify it as a normal. But skipping to the next one, it says the parent population is normally distributed. Where's the parent population? I don't see it. It talks about the sample.
I don't even, the sample is 10.
Yeah, but in the next one, how do you know that distribution of the sample mean has this shape? So it goes, so both A and B work together. Well, we said it's normal because that's what it says, but how do you know? And it talks about in the key, it says the parent population is normally distributed. I mean, what does that mean? I mean, I don't understand. It's not
We're
large
the
enough.
blind leading the blind, because
Yeah.
whenever I look at it, I mean, like I said, I did everything I was supposed to, and I feel like I'm still,
Yeah.
because even when I did D initially, I did it wrong because I didn't know I needed to have my graphing calculator or whatever it's called.
Yeah.
And I got it, and then I could find the answer, you know?
Right. I mean,
And I followed that formula that you just showed me, and it works.
mhm.
Like that's my point. I feel like it's vague. They should say, using your graphing calculator, calculate the standard deviation of the distribution of simple mean scores for all such samples.
Right.
And I guess maybe I should know that, but nowhere in the syllabus does it say that you're going to need a graphing calculator, does it? Maybe I missed that.
Nope, it doesn't. I just,
Yeah.
a lot of things I'm using now, I don't even have a graphing calculator. I use my phone for my calculator, and I use Excel by putting in just, standard deviation and stuff like that. I have to, so, but.
Well, I used my phone for for AD, 8D, and it didn't come up right. I used the calculator on the computer, and it didn't come up right. And it gives you the option to be scientific.
Well, I had to, yeah. Well, I can show you how to do it on your phone and it's on how to get that if you want me to do.
Well, now I have my calculator, so.
And you calculator can figure it out, great. So.
Yeah. I got the calculator.
That's great.
I'm just saying, like, when it's in the terms of words, I don't know, because I couldn't tell you where B or A came from. Because I had to look at the answer key because I was going to try to work backward from that. But I just feel like there's not enough information. So.
Well, the only way I can say it's a normal is because we're talking about normal. So that's when and then you do that because normal is based upon population. So therefore, there's your answer. So it's a law of it's not a law of deduction. It's the law of elimination. We haven't talked about anything else but normal distribution in this. So that's the only thing I can go off of. So going with 8C. Just skipping to that, it's 529 because it's the population, and then the standard deviation.
Easy.
Yeah, I like that one. And then how you do it is 113 over the square root of 10, and that's how you get your standard deviation for the sample mean. So that being said, I mean, I think it's clear, about as clear as mud, but I think we're ready to go on to the.
I'm glad I'm not the only one who feels that way.
Well, all right. Let's stop sharing. Oops, hold on. Stop. All right. Do you think we're ready now for going on to the test?
Yeah. I mean, we can figure this out, can't we?
Yeah. I don't think we're going to have a problem. I mean, I think we've done good so far. I don't think we're going to get stumped on this one. And the nice thing is we get a second chance. All right. I'm going to stop broadcasting. All right.
Okay.
Cool. Thanks.